Right, this is our main system module, and this just handles the clock for the VGA as well as the PS2 interface. Right here is the PS2 clock, and then this handles the keyboard input. This clock here is just used to update the status of the last key press approximately 3 times per second. And this is looking for specific key codes. The space bar will reset A and B to 0, and the left, right, up, and down keys will either increment or decrement A or B. This right here is just used to draw in the upper left corner of the display output a square, which its height and width will be the current value of the ALU output. And then these colors here define the difference between the square and its background. This clock wizard we generated, it's approximately 25 megahertz per the VGA standard, 25.2 exactly, which we just used the Vivado clocking wizard for. And then this generates the horizontal and vertical sync signals using the VGA protocol. And then we just have this to handle the data input from the PS2 interface, as well as our updated ALU,
which I'm going to talk about. So basically, we just added more bits for the inputs and the output as well. And we're using like a carry select adder, which is right here, which has like 8 bits as well, and the carry select subtractor, which has the negate function in it as well. And basically, it's like the regular ALU did in lab3, which has the mode through that does like the various operations between the two inputs, and the output goes directly.
All right, so basically what we have here is a keyboard with a USB interface. Well, it's PS2, and then our VGA output here. And we've updated the ALU to use 8 bits, and rather than use the switches as the inputs for A and B, we're just using the arrow keys on the keyboard and the space bar. So this first slide switch here will show either A or B depending on its position. And you can see these control the up position, left and right control the down position. So a right press will continue to increment until another key code is detected, and then left will decrement also until key code is detected. Same thing here. Up is increment, down is decrement, and you can see that it will roll back. And this is just displayed in binary, all 8 bits on the 7-segment display. So these 4 other switches correspond to the 4-bit instructions. Same decoder as the first ALU, and also the spacebar is set up as a reset to 0. So we'll start with 0. We have 0, 1, 0, 0, which is A plus B. So we will start, if you look at the display here, we will start incrementing, and we can see that the square will begin to grow in width and height. So if we stop that and then switch, starting from 0, the square will continue to grow. If we stop, we'll go backwards, we will go past 0 and continue, reset back to 0 gives us 0. see that that works for A and for B. So we'll also demonstrate A and B, which is 1, 0, 1, 0. And theoretically, if we were to increment A and B at the same time, the square would grow linearly with time, but we can only increment 1 at a time. So I will try to do an increment of 1 there, or we'll just go to a value 1, 1, 1, 1, and then switch over and also set this to 1, 1, 1, 1. And we can see that the square has grown. And if we try, say, 1, 1, 1, 1, 1, and then do the same here, we'll see miss it. And then if we go, say, roll over to 1, 0, 0, 0, that should be zeros for output, which we can see right there that happens. And then as these bits fill in to match the other input, it will grow and then decrease back to 0. And that's pretty much it. So we decided that we wanted to use the keyboard, and looking into it, I realized that it would be tricky to detect multiple key presses at once, and also to detect the release of the key. Initially, we wanted to be able to hold down the key and then release it, and only detect an input when it's held down. But then we realized that with a reset and being able to cancel it, it does make it a little bit trickier to input precise numbers, but you can still more or less get where you want to go, demonstrate the VGA output. And it is sort of convenient to be able to just press the key and not have to worry about holding it down, and just let it continue to loop or whatever you want to do.
So at first we wanted to display each number on one of the 4-digit 7-segment, but we thought it was better to display each number as a binary on the 2, 4, 7-segment digits. And so we added like a switch here that would switch the display between the two numbers. And the output is shown on the VGA as shown before.